Practice problems on concurrent forces, part 2. Mrs. Nugent has attached a sign that has a weight of 550 newtons to a wall outside her office. The sign hangs on the end of a metal rod, and a cable attached to the end of the rod where the sign is hanging makes a 30-degree angle with the rod. The chain is attached to the wall above the rod. Find the magnitude of the tension on the chain and, part B, the thrust force into the wall exerted by the rod. Practice problems on concurrent forces, part 2. Ms. Nugent has attached a sign that has a weight of 550 newtons to a wall outside her office. The sign hangs on the end of a metal rod, and a cable attached to the end of the rod, where the sign is hanging, makes a 30-degree angle with the rod. The chain is attached to the wall above the rod. Find A, the magnitude of the tension on the chain, and B, the thrust force into the wall exerted by the rod. One of the tricky things about this problem is drawing the picture accurately. So here we have a wall, and Ms. Nugent's sign is hanging on the end of a metal rod, which is supported by a chain attached to the wall above it. The chain makes an angle of 30 degrees with the horizontal. So here we have a sign hanging on the end of a rod, which is supported by a chain attached to the wall above it. We know that the weight of this sign is 550 newtons, and that weight is a force that acts in the downward direction. Now, there's another important fact about this problem that's not stated in the problem, but we understand that nothing is moving. In other words, the sign is in equilibrium. This is another way of stating that all the forces acting must be balanced. So that if there's a downward force called weight, we know that there must be an equal and opposite upward force. And that force is supplied by the vertical component of the tension on the chain. So I will draw an upward force. It's tricky to know just how long to make this vector. But since we know that it is a component force of the tension on the chain, then it must form a right triangle. It must be mutually perpendicular to the horizontal component of that tension. In other words, this will always be a right triangle. Don't confuse the physical objects that are pictured here in the drawing with the actual forces that are acting in those directions. It's the forces that we're interested in. So the length of the chain and the size of the sign, they're actually irrelevant. If there's a down force of 550 newtons, then the vertical component here must also equal 550 newtons in the upward direction. We know that due to geometry, alternate interior angles are equal. So I can use trigonometry in order to find the hypotenuse of my right triangle here. So for part A, to find tension, sine of 30 degrees must equal my vertical force divided by the hypotenuse, which is the tension on the chain. Sine of 30 degrees equals 0.5. The upward vertical force is 550 newtons. So the tension on the chain must equal 550 divided by 0.5, or 1,100 newtons. Now for part B. Part B asks, what is the horizontal thrust of the rod shoving against the wall? So we could call this force of thrust, but it is acting along the rod here. We note again that there is an upward component That's equal to 550 newtons. Therefore, by the parallelogram method, this component acting upwards along the wall must be 550 also. We know our angle is 30 degrees, so through trigonometry, the cosine function would allow me to find the adjacent side of this triangle. So cosine of 30 degrees will give me the force of thrust divided by the tension on the chain, which we found in part A. So 1,100 newtons times the cosine 30 degrees would equal thrust. 953 newtons is the horizontal thrust acting along the rod. Now it's time for you to try some practice problems. Pause the video as you read each problem, and then when you have your answer, press play so that you can check your work. Here's practice problem number 1. Connie hangs a 14 Newton hummingbird feeder in the middle of a rope tied between two trees. The feeder creates a tension of 300 newtons in each side of the rope. If the two trees are 2.5 meters apart, how much will the rope sag in the center? Pause the video, and after you've worked it out, press play again to check your answer. The answer is 0.03 meters. Practice problem 2. Two shipwrights, shipbuilders, are carrying a plank, which is a board, of oak to the shipyard, carrying it level with the ground. One of the shipwrights exerts a force of 200 newtons at 50 degrees above the horizontal, and the other exerts a force of 380 newtons at 45 degrees above the horizontal. What is the total upward force exerted by the shipwrights? Pause the video, and after you've worked your problem out, press play to check your answers. The answer is a total force of 422 newtons. Practice problem 3. A traffic light is supported by two wires that make an angle of 86 degrees with one another. If the maximum tension in each wire is 720 newtons, what is the maximum weight of the light they can support? Pause the video, and when you've finished with your work, press play to check your answer. The answer is 1,053 newtons. This concludes our practice problems on concurrent forces.